Hello and welcome to my YouTube channel. In this video we are going to discuss the differences between single point cutting tool and multi-point cutting tool. So first we have to understand what is the purpose of cutting tool. So basically cutting tools are used for removing the material from the workpiece. The material in front of the cutting tool gets sheared off, or it is subjected to the plastic deformation and it is get removed from the workpiece. So that is the purpose of cutting tool. Now the cutting tools are classified into three basic categories. The first one is single point cutting tool, the second one is double point cutting tool, and the third one is multi-point cutting tool. But sometimes the double point cutting tool can be referred as a multi-point cutting tool. So we can broadly classify the cutting tools into two categories, that is single point cutting tool and multi-point cutting tool. So let's discuss their differences. So the very first difference in between single point cutting tool and multi-point cutting tool is single point cutting tool contains only one main cutting edge in the cutter body. So here you can see the diagram of single point cutting tool on the left hand side, and the cutting edge or the cutting action takes place with the help of nose only. So the portion here, this portion is known as nose of the cutting tool, and the cutting action takes place due to this portion only. So the single point cutting tool contains only one point through which the cutting action takes place. In case of multi-point cutting tool, it contains more than one, even up to hundreds cutting edge in the cutter body. So the figures at the right hand side, that is nothing but multi-point cutting tool. So this is a diagram of side milling cutter, this is a plane milling cutter, this is a plane milling cutter, and these are the drill bits. So here you can see the plane milling cutter or the side milling cutter has number of cutting edges. So these are nothing but its cutting edges, and with which you can remove the material. Whereas in single point cutting tool it has only one cutting point. So the multi-point cutting tool contains more than one cutting edge and through which the cutting action takes place. Here also you can see the number of cutting edges. These are also the cutting edges of drill bits with which you can remove the material. So that is the first difference. The single point cutting tool contains only one cutting edge, whereas the multi-point cutting tool contains more than one cutting edge. Now we will discuss the second difference. The second difference is, while machining with single point cutting tool, only one cutting edge continuously remain in contact with the workpiece. So here with this diagram you can understand this. So this is the workpiece, this is nothing but your workpiece, and this is the cutting tool, right? And this cutting tool is removing the material from the workpiece in form of chips. So these are nothing but the chips which are flowing over the face of the cutting tool. Now this is a single point with which the cutting action takes place, right? So while machining with single point cutting tool, only one cutting edge continuously remains in contact with the workpiece, right? In case of multi-point cutting tool, while machining with multi-point cutting tool, more than one cutting edge simultaneously engage in material removal action in a pass. So here you can see a face milling cutter. This is an example of face milling cutter. This is your face milling cutter, and it has number of cutting edges. So it has number of cutting edges. These are nothing but the cutting edges of your face milling cutter or multi-point cutting tool. So the cutting action takes place with multi-points. Okay, so while machining with multi-point cutting tool, more than one cutting edge simultaneously engage in material removal action in a pass. So that is the second difference. Now we will discuss the third difference. Third difference is, chip load per tooth is usually high in single point cutting tool. So here you can see, as only one point is in contact while machining, so entire cutting force will act over that point only. So the chip load per tooth is usually high in case of single point cutting tool. So this is a shear plane, okay, and whatever the cutting load, that will act over this point only. Whereas in multi-point cutting tool, due to presence of multi-cutting edges, effective chip load per tooth is reduced. So here you can see number of cutting edges are there, and with these cutting edges the cutting action takes place. So whatever the cutting force is, that will going to act on this number of points. So the chip load will get distributed over these points, and obviously the effective chip load per tooth will get reduced, and that is not happening in single point cutting tool, right? So in single point cutting tool the chip load per tooth is usually high, whereas in multi point cutting tool, as it has a multiple cutting tooth, that is why the chip load is get reduced. Now we will discuss the fourth difference. So in single point cutting tool, since the one cutting edge continuously remains in contact with the workpiece, so the rate of heat generation and subsequent rise in tool temperature is high. So here you can see only one cutting edge is in contact, okay, or only one point is in contact with the workpiece. So due to this, what happened? There is a rise in temperature, or there is a high rate of heat generation. As there is only one point is in contact, so it has very low surface area, and hence the heat generation is more, and hence the temperature is more. So in case of single point cutting tool, there will be high temperature during the machining. The high temperature will get induced during machining when you will use a single point cutting tool. Okay, in case of multi-point cutting tool, due to successive engagement and disengagement, heat dissipates from the cutter when it is in non-contact with the workpiece. Consequently, the rate of rise in tool temperature is low. So here you can see this is a milling cutter, this is a end mill cutter which is in contact with the workpiece. So this portion is nothing but the workpiece, which is shown in green color. Now the cutting takes place, and during cutting, what happened? There is a successive engagement and disengagement of the cutting edges with the workpiece. Here what happened in single point cutting tool? This single point is in contact with the workpiece continuously. That is why high rate of heat generation is there and temperature is more. Here what happened? The cutting tools are successively engaging and disengaging. That is why when there is a disengagement, the heat dissipates from the cutter when it is not in contact with the workpiece. So consequently, the rate of rise in tool temperature is very less. So that is the next difference. Now the another difference is, in case of unplanned breakage of the cutting edge, entire process is required to pause until the broken tool is replaced by new one. So here you can see some images of broken tool. These are nothing but the insert which you have to clamp over the cutting holder. Now these are broken. So when it is get broken, you have to replace this insert with the new one. And while replacing those insert, you have to stop your entire machining activity. Okay. So that is what it is written here. In case of unplanned breakage of cutting edges, entire process is required to pause until the broken tool is replaced by new one. So you have to replace this insert with a new one, or you have to change its cutting edge. Whereas in multi-point cutting tool, if one cutting edge breaks, cutting action can be continue using other cutting edges without much problem. So this is nothing but an example of milling cutter. Suppose in this case, if one insert get broken, right? So you can machine the component with the help of other insert, right? So you need not to stop the entire activity. You can carry out your machining processes, and after that you can replace this insert. So that is possible in multi-point cutting tool, which was not possible in single point cutting tool, because you have to replace that insert. As you are using only one insert at a time, so you have to replace that insert, or you have to fix that insert again. But here, as the one single insert get failed, you can remove the material with the help of other inserts. So that is another difference in between the single point and the multi-point cutting tool. Now the next difference is, design and fabrication of single point cutting tool are easier. Okay, and the design and fabrication of multi-point cutting tools are quite different. So here I am showing the single point cutting tool as well as multi-point cutting tool. So here you can see the construction of single point cutting tool is very simple. You can easily fabricate it. So it is easier to fabricate the single point cutting tool, whereas if you carefully look the images of multi-point cutting tool, its shape is very complex. So design as well as fabrication of multi-point cutting tool is quite difficult, and that is get cleared with the help of these two images. Now the next reference is, usually low feed rate and depth of cut is employed when machining is carried out with single point cutting tool. Accordingly, material removal rate, that is MRR, and productivity are low. Okay, so as the cutting takes place with the help of single point only, so you have to keep very less feed rate and depth of cut, because the cutting action takes place with the help of single point only, right? So entire cutting force will get act over a single point only. So you have to keep low feed rate as well as low depth of cut, and hence there will be low material removal rate, and hence the productivity will be low. Whereas in multi-point cutting tool, higher feed rate can be employed when machining is carried out with multi-point cutting tool. This increases the material removal rate and productivity. Accordingly, machining activity becomes economic. So as the material is get removed with the help of two or more than two cutting edges, obviously more material will get removed. So obviously you will get more material removal rate, right? And hence your productivity will get increased and it will become economical. In case of single point cutting tool, the material is removed with the help of single point only, so it is uneconomical as compared to multi-point cutting tool. Now the last point, these are nothing but some examples of single point tools and the multi-point tools. So the examples of single point tool is turning tool, which is basically used in lathe machine, then the shaping tool used in shaper machine, planing tool used in planer machine, then slotting tool used in slotter machine, boring tool which is used in lathe machine or in boring machines. So boring is the operation of enlarging the previously drilled hole. So that is boring, and for that boring purpose you have to use the boring tool, and then the fly milling cutters. Okay, these are some examples of single point cutting tool. The examples of multi-point cutting tools are milling cutter, which are basically used on milling machines for the milling purpose. Then the hobs are there. Then broaches, which is used in broaching machines. Then grinding wheels are there. So grinding wheels has a number of cutting edges, even 1000 cutting edges are there, and the material is removed with the help of those abrasive particles. Then the reamer is there for finishing the hole, and the knurling tool for generating a diamond shaped pattern over the workpiece. You can use knurling tool also. So with the help of some diagram, here I am representing these tools. So the very first diagram, that is a turning tool. So this is an example of turning tool, and this is basically used over a lathe machine. This portion is known as the tool holder, and this is a cutting insert. The cutting insert has to clamp over the cutting holder, and when it is get worn out, you have to simply remove the cutting insert, and then you have to fix the another insert. So that is a turning tool. Then the second image, this one is a fly milling cutter. The third one is boring bar. So bearing bar is generally the turning holder that is in cylindrical shape, and this is a cutting insert. Okay, this is basically used over a lathe machine, and boring is nothing but an operation of enlarging a diameter of previously drilled hole. That is the purpose of boring tool. And the next one is slotting tool. So here these tools are used for cutting the slot over the workpiece. So these are some examples of single point cutting tool. So here you can see, if you carefully observe it, it has only one point with which you can remove the material. Then the next one is, these are the images of multi-point cutting tool. So the very first one, that is side face milling cutter. So this is a cylindrical side face milling cutter with which you can remove the material, and it has number of cutting points. Then the second image, this is plain milling cutter. The third one is reamer. Okay, the third one is reamer. Again, this reamer has number of cutting edges, and this reamer is used for finishing finishing a available hole or a drilled hole. That is the purpose of reamer. And the next image, that is a broaching tool. So these broaching tools are used over a broaching machine, and again it has a number of cutting tools. So broach are basically used for generating the internal gears, you can say, or for cutting the threads, internal threads, you can use the broach. And then the last image is the knurling tool. The knurling tool can be used over the lathe machine, and it is basically used for generating a diamond shaped pattern over the workpiece for gripping that object. Okay, so these are nothing but some examples of multi-point cutting tool. Obviously there are lot many cutting tools available which is having multi-point cutting tool. One of the example is grinding wheel also. So the grinding wheel contains the abrasive particle over its periphery, and with those abrasive particle you can achieve a higher kind of finish as compared to other processes in grinding process. So that is all about the single point cutting tool and the multi point cutting tool. Hope I have cleared everything about single point cutting tool and the multi point cutting tool. Thank you so much for watching my lecture. Thank you.